Over the years, many different systems have been suggested for how to classify living organisms. Aristotle originally suggested a system that he called the ladder of nature, or the great chain of being, where all living organisms were organized on a linear scale from lower to higher animals. The first really successful system that was devised was suggested by Carl Linnaeus, a Swedish scientist that lived in the 18th century. The system that he suggested, which was published in his book Systema Naturae, is essentially the system we use today with some modifications. Systema Naturae was first published in 1735, and over the next decades, numerous other editions or further editions were then published. The system that Linnaeus suggested was one based on a nested hierarchy of groups, a grouping of groups within groups. The basic level, the lowest level of his system was the species. And many of you probably have some intuitive understanding of what a species is. But as it turns out, when you try to really nail down a good definition of species, it turns out to be not so easy after all. Typically, what we think about when we say species is the so-called biological species concept, first suggested by Ernst Mayr. In the biological species concept, we say that a species is a group of organisms that interbreed and that do not interbreed with other groups of organisms, and where their offspring is fertile. This is a very good definition for sexually reproducing organisms, but you can see that it doesn't work for asexual organisms, such as, for instance, bacteria. It's also not a definition you can use on organisms where you don't know their reproductive habits, such as, for instance, fossils. Nevertheless, most of you probably have some intuitive understanding of the term species, and if you think of it as a group of organisms that somehow resemble each other, that have pretty much the same genome, then you're probably not far off. Be that as it may, the species is the basal level of Linnaeus's classification system. The idea in Linnaeus's classification system was then to group similar species into genera based on their morphological similarities. So if you have several species that somehow resemble each other to a sufficiently large degree, then they would all be placed in the same genus. Similarly, if you have several genera that somehow resemble each other, they would be placed in the same family. Families would be placed together into orders, orders into classes, classes into phylums, and phylums into kingdoms. This is the nested hierarchy of Linnaeus' system. If we depict it in the form of a tree, you can more clearly see perhaps how this nested hierarchy works. So at the top right of the slide, for instance, you can see two species that resemble each other to a great degree: the coyote and the wolf. These two species are so similar, you can see they share a lot of these dog-like features, and they're therefore placed into the same genus, namely the genus Canis. Moving further left on the slide, you can see that the otter and the skunk, again, they are animals that share numerous features. They have traits in common. They have these elongated bodies, short legs, small rounded ears, and many other things in common. But also, they obviously have quite a few differences. They are therefore not in the same genus, but are instead placed in the same family, in this case, the Mustelidae, or the weasel-like animals. Finally, we have the leopard on the extreme left there. Again, it obviously shares features with the rest of the animals on this slide, but also it has a great deal of differences, and it's therefore not in the same genus or the same family, but it is placed in the same order as all the other animals on this slide. Incidentally, one thing that Linnaeus also included, or that he invented and that we still use today, is the way of naming organisms. You'll notice all these organisms have these bipartite names. They have names composed of two parts. The parts are Latinized, and you'll notice that the first part of each name is in fact the name of the genus, and the second part of the name is then a name that's specific to that particular animal. So, Linnaeus suggested this nested hierarchy system, this system of groups within groups. It's shown on this slide also, where the species are the leaves, genera are groups of species, families are groups of genera, etc., etc., up to the entire tree, which is in this case the kingdom. And the interesting thing was that Linnaeus' system was actually quite successful. It was successful in the sense that it really appeared to reflect some aspect of reality. There was a natural way in which animals would fit into the system. For instance, looking at the group of all animals, it was natural to define a group of animals with backbones, or what we now call vertebrates. A subset of vertebrates, it turned out, had fur and mammary glands, and it was therefore natural to define the group of mammals, which was then a grouping inside the group of vertebrates. Similarly, a subset of mammals had cat-like features, and it was therefore natural again to define the group Felidae inside the group of mammals, inside the group of vertebrates. So this nested hierarchy of groupings appeared to reflect how real animals grouped naturally. And it was successful in the sense that this was robust and apparently objective. You had two different scientists try to organize or try to classify the same group of animals, they would probably come up with quite similar systems. There would be something like a vertebrate group, and within that there would be a group of mammals, and within that a group of cat-like animals, for instance. So it was robust and apparently objective. And this is actually different from other things that you might try to classify in a nested hierarchy of groupings. So as an example, try for instance to imagine that you want to classify photographs. Imagine you have a few thousand photographs on your computer and you're trying to classify them in a nested hierarchy of folders. So you have folders within folders within folders, and you want to find some system for uniquely being able to put any given photograph inside one of these folders. So one system you might come up with. Imagine, for instance, you have two photographs. One is a view taken in 1995 on top of the Empire State Building while you were on summer vacation in the US. Another is a view taken in 2013 on top of the Empire State Building, again, while you were on summer vacation in the US. So imagine one system for organizing these. Imagine you have at the top level one folder called private, one folder called work. Inside the private folder, you might have various folders for at home, summer vacation, skiing, etc., etc. Inside your summer vacation, you might then have one folder for each country that you've ever visited. And under this system, the two photos of you on top of the Empire State Building would be placed together in this folder, the folder for the US. This is a fairly stringent system, and there would probably not be much doubt about where to place any given photograph. However, it's not necessarily objectively the only correct way of classifying your photographs. Another system would be that you had, as at the top level, a folder with the year in which the photograph was taken, and you had then folders going back to 1993 or whenever you started taking photographs, and then one folder for each year. Within each of these folders, you could then have 12 folders, one for each month of the year, and within these you might have a third level, one for each day in the year, or maybe one for each week in the year, depending on or in that month, depending on how you wanted to set it up. Under this system, since the photographs were taken on different days and different years, they would not be placed together. Again, it's a stringent system, and any given photograph would fit into one spot, but you can see that there are two completely different, equally stringent systems, that there's not one of them that's objectively better than the other. However, that was exactly the case for the animals. Cat-like animals really do form a natural grouping within mammals, which is a natural grouping within vertebrates. So somehow Linnaeus seemed to be onto something. There was an aspect of reality that his system reflected. It wasn't really until about 100 years later, when Darwin published On the Origin of Species in 1859, that anyone came up with a good scientific explanation for why this was so. And the reason Darwin said that Linnaeus' system of nested hierarchies, groups within groups within groups, that this system worked so well, was that in fact all life on Earth is related through the process that he referred to as common descent with modification, in the sense that all life forms on Earth, all species on Earth, have derived from one original group of organisms, one original ancestor that was present, we now know, about 4 billion years ago. This original population, this last universal common ancestor, this population at some point split into two subpopulations that went their separate ways, acquired mutations, etc., until they had formed two separate species. Each of these then again split and resplit, forming this tree-like evolutionary history where species are related to other species in this manner. And what Darwin said was that the nested hierarchy in Linnaeus' system was actually just a manifestation of the underlying evolutionary history. So if two animals resemble each other to a large degree, like for instance the wolf and the coyote, then that's because they shared a common ancestor not too far ago, not too many million years ago. There's been a population of pre-wolves, some wolf-like animal. This population split into two. One branch went off to form the wolves, the other went off to form the coyotes. And the more dissimilar two species are, the further back in time we will have to go to find the common ancestor. The common ancestor between a wolf and a leopard, for instance, we have to go further back in time to find that particular common ancestor. So, and today, incidentally, when we do systematics, when we do classification, we explicitly base it on phylogeny. If we say today this animal is a mammal, then we're actually making an evolutionary statement. We're saying it shares a common ancestor with this other group of animals.